Hello, I'm going to describe how Placidus house cusps are calculated. I have another tutorial video where I explain how many house systems are calculated, such as Campanus, Regiomontanus, etc. And I mention a little bit about Placidus, Alcibiades, and Koch. I don't go into those three house systems in detail. And in this video, I'm going to go into more detail about Placidus houses and describe exactly what they are and how they work. They're very interesting, as you're going to see. And also something called true Placidus house positions that are slightly different from the normal house positions. Okay, now here is the underlying concept behind Placidus houses. The idea is this. The sun is in the 12th house if in its journey from rising to culminating it is in the first third of this journey. So let's look at a chart wheel. This is a chart wheel it happens to be for December 23rd, 2014, and the sun is over here in the 7th house. We want the sun in the 7th house if it's in the last third of its journey from the midheaven to the 7th cusp. As you know, the planets rise in the east, they culminate overhead, even though this is not halfway between the ascendant and descendant. This is actually the halfway point, as I describe in other videos on astronomy for astrologers. But as the planet rises in the east, culminates at the 10th cusp, and then it goes through this quadrant, the idea of Placidus houses is spend an equal amount of time in the 9th, 8th, and 7th houses. Sounds like a good idea, doesn't it? And similarly, in this quadrant, the 10th, 11th, and 12th houses, we want the sun to spend an equal amount of time in each house. And you might think, well, to do that, why don't I just divide from the midheaven to the ascendant in equal sizes? That would be the porphyry house system. Won't that do it? No, it ends up it doesn't. And maybe somewhat surprisingly, the 12th house is very large compared to the 10th house. But nevertheless, the sun, in its travel, its diurnal motion, its travel through the day, would spend as much time in the 10th, 11th, and 12th houses. That's the idea. It's intuitively very appealing. What's appealing about it is that diurnal motion is closely connected to houses, isn't it, right? You have basically two motions. You have diurnal motion, and then you have what you could call proper motion. Proper motion is, here's the sun in early Capricorn, moving, taking a month to go through the sign of Capricorn, another month to go through Aquarius. That slower motion is the motion through the ecliptic plane, and then we have the fast motion, the daily motion of all the planets spinning around. So houses reflect that daily motion. The planets are changing houses every 2 hours. So the idea is to have the sun spend equal amounts of time in each house. Well, you might say, why am I talking about the sun? Don't you want all the planets to spend an equal amount of time in each house? Yes, actually it's all the planets, but a technical detail about it is that in astrology, as I mentioned in the tutorial videos, Astronomy for Astrology, we don't actually use the planet positions. What do you mean we don't use the planet positions? I thought I was using the moon. Well, technically speaking, you're not using where the moon actually is in the sky in astrology. Usually we're projecting the moon onto the ecliptic plane. So we're using projected positions onto the ecliptic plane, technically speaking. And in the Placidus houses, it's the projected position on the ecliptic plane that is spending 1/3 of its time in each house. So, for example, here's Mercury at the end of the 7th house, right? It's at 10 Capricorn, 10 degrees Capricorn. The 8th house is 12 degrees Capricorn. I do have Placidus houses selected. So Mercury has spent 1/3 of its time in the 9th house, another third in the 8th house, and so it's a little more than 2/3 of its journey towards the 7th house, because it's just past the 8th house cusp. Remember, the planets go backwards through the houses. But technically speaking, is it actually Mercury that has traveled 2/3 of its journey because I know it's a little more than 2/3 because it's a little bit before the 8th house cusp. No, it's not technically Mercury. It's Mercury's projected position on the ecliptic plane that is a little more than 2/3 of its 2/3 of the distance towards reaching the descendant. And the sun is on the ecliptic plane by definition, so there's no projecting involved. So for the sun, it works perfectly because it always has no latitude. Now, I've taken this chart wheel in the Series 2.0 software, went into Page Designer, and added a table of latitude. Why did I do that? Because the larger the latitude, notice the moon has a fairly large latitude, almost 5 degrees. So for a planet with a large latitude, more than, say, 2 degrees or so, you start to get a more significant difference between the actual moon and the moon we use in astrology, which is the moon on the ecliptic plane. So the bottom line is this. What are Placidus houses all about? They're all about keeping the planets 1/3 of the time in each house within a quadrant. Technical note, it's not actually the planet, it's the planet's projected position on the ecliptic plane. And for the sun, there's no distinction because it's on the ecliptic plane. So you don't have to worry about that difference. If you wanted to know if the actual moon, not the projected moon on the ecliptic plane, is in the 8th house, or a better example would be Mercury is very close to the cusp. It's possible that the actual Mercury, not the projected Mercury, is in the 8th house. It's possible. We might want to know that. And that's what I mean by the true Placidus houses. The true Placidus house means where the actual physical body is. The usual Placidus houses tells us where the projected position on the ecliptic plane is. Which one do you want to use? Well, these are things that are always debated in astrology. Some people say don't use Placidus houses at all. But if you are going to use Placidus houses, there's a choice of using the usual Placidus house or the true Placidus house. How would you know what the true Placidus house position is? You would need a table that would just list that position for you and tell you how far into the 7th house Mercury is. Or possibly the true Mercury position is at the beginning of the 8th house. Or actually, it's at the end of the 7th, or maybe it's the beginning of the 8th. It gets confusing because the planets are moving backwards through the houses. So you would just need a table because you can't put true positions in a wheel. You just can't do it because as soon as you use true positions, you can't put those on a piece of paper. You can't put them on a computer screen because it's not two-dimensional. The whole sky is a sphere, and when you start taking into account latitude, you're not just using that ecliptic plane, that great circle as we call it, and there's no way to draw it in a circle, and no simple way anyway. So you can just have a listing, and I'll show you in the Series 2.0 software how you can get that listing. Okay, we've covered a lot of material. Let me summarize. What's the underlying idea of Placidus houses? Underlying idea is you want the planets, and when I say planets I mean their projected positions on the ecliptic plane. We want the planets to spend an equal time in each house within the quadrant. It's similar to the porphyry houses. Where the porphyry houses, you take the distance from the midheaven to the ascendant, you divide it into equal thirds, but that's dividing the longitude in equal thirds. Here what you're doing is you're doing it in mundo. You can look at Placidus houses as similar to porphyry, but done in mundo. In mundo means the relationship of the horizon to the meridian plane. And when you do it in mundo, the planet is spending 1/3 of its time in each one of these sections. So that's what Placidus houses, that's the concept behind them. All right. And if you think that sounds complicated, try to read other explanations of it. It gets even more complicated. It is what it is. The ancient astrologers, many of them were astronomers, and they studied these motions carefully, and they used it. Okay, so now I'm going to give you some idea of how that is calculated, just so you have some idea about it. And there's one good reason to know this. Because in understanding how we find out where to put the 12th cusp so that the planets are spending 1/3 of their time in the 12th house, it makes us understand some things about daily motion, how the planets travel through those, let me go back to this, roughly 6 hours, roughly 2 hours. How does a planet move through that? This is so important in medieval astrology. They put huge emphasis on how the planets travel through the day. It's the foundation of primary directions, major forecasting method. They didn't use secondary progressions, as far as we know, through most of the Middle Ages. But they did use primary directions, which are based on daily motion. And we've lost a lot of this in modern astrology. And this sky, picture of the sky, shows you the daily motion. This looks like a painting, but you know what? This is actually a photograph done by an astronomer of the sky with a time-lapse feature where you're essentially overlapping what you see minute by minute or every few minutes in the sky over a large number of hours, most of a night. And what happens is the planets rise. Now he has his camera facing north, and this little round thing is the North Star, or called Polaris. If you face north, which he did to take this picture, where is east? So take a minute, face north. East is going to be where? It's going to be to your right. In an astrology chart, east is to the left. So here's an astrology chart, and here's east to the left. So what's the deal with that? Why is east to the left in an astrology chart, and why is east to the right in this picture? Because the astrology chart is made if you face south. You may or may not be aware of that. I talk about this in the videos on astronomy for astrologers, but we're facing south, and we have east to the left. It's not that important, but just to be technically correct about this, this is east to the right. So let's take this white circle. What is this white circle? This is actually a photograph of the sky showing where a star is over time. If you take a picture of the sky every, say, 10 minutes or 15 minutes or every minute, and you overlap those pictures, you're going to see that this star rises and arcs this way, comes up here. Here it looks like it got cloudy or something, so it was not so bright. Continues, it would continue up past the area with a picture, the area of the sky that he's taking a picture of, and it would come back down around, it looks like it's probably around here somewhere, and make this perfect circle. So everything spins around in a perfect circle. It's an optical illusion created by the rotation of the Earth on its axis. So when we talk about the sun spending 1/3 of its time in each house within a quadrant, 1/3 in the 12th, 11th, and 10th houses, the sun is going to, like everything else, is going to make one of these circles. And what we want to do is divide that into thirds. That's the basic concept of Placidus houses. So it takes us into an awareness of this beautiful thing that happens in the sky. I think if we could take this picture and get in a time machine and go back to, say, when Placidus lives and say, guess what, I just traveled here from a time machine and we have this fantastic technology in the 21st century, and here's a picture of the sky taken over time. Placidus would look at this and probably say, oh my God, this is fantastic technology. It wouldn't surprise him because the astrologers were so keenly aware of this motion. And it seems like we're barely aware of it now, even though we have technology to show us pictures of it. Okay, so these diurnal arcs are how the planets move through the day. They're closely connected to the idea of houses, and they are used to calculate Placidus houses. So here's a diagram where I have a red dot here. This could be a star that's rising. Where would that star be about 2 hours later? If it's here at one time, where would it be 2 hours later? Would it come straight up? How would it go? It's going to follow the circle. zoom, it's going to be about there. And where's it going to be 2 hours later? 2 hours later, it's going to follow, come around, it'll be there. And 2 hours later, I'm saying 2 hours, however, on average, 2 hours, could be an hour, could be 3 hours. It's going to be here. So whether you divide it by time or by space is the same thing, because this daily motion is perfectly constant. That's something to be aware of. That daily motion, well, it's not, nothing's perfect, is almost perfectly constant. Why would this motion be so constant? Because the Earth is spinning on its axis. And the Earth spins on its axis in a very constant motion. It changes only over very long periods of time. Otherwise, you get more sleep one night than another night. So we know that the days from one day to the next are almost perfectly the same length. And the planet does have, if it's a planet, does have a little bit of motion in the opposite direction, but it's relatively little. So we can think of this, whether we think of it as time or space, it's basically the same. So we're dividing this diurnal path of the planet into thirds. And in fact, the way the calculation is done is by space. This arc is divided into 1/3. 1/3, 1/3, 1/3. And then we have to somehow relate this to the ecliptic plane. Same problem we have with all houses. We're dividing something into equal sections. Here we're dividing the diurnal path of the planet. This is called the semi-diurnal arc. This half of the arc. And this other half is the same size. There's a semi-nocturnal arc, which is below the horizon. Anyway, we're taking this path from rising to culminating and dividing it into 3 equal sizes. Now our problem is, how do we connect that to the ecliptic plane? And I'll show you how that's done. With Placidus houses, it's very clever and I would say rather impressive. It's elegant. Now I've described all this, and I've discussed all this. These are just my notes to make sure I cover these things, and I've covered all of this. So we are up to this diagram which shows how the Placidus houses are calculated. And here's the idea. Let's look at this blue thing. Basically, we have the same picture we had before with some of my scribble on here. And one of my scribble is this blue, it's like a rainbow that goes from one end to the opposite end of the sky, only it's not nice and symmetrical like all these diurnal paths. And this is the ecliptic plane. This is the path of the sun. The path of the sun at any particular time during the day wobbles around the sky. And at this particular time of day, I'm just making believe that the ecliptic plane goes from here up in this, think of it as a rainbow, big arc coming up and coming down there. I don't know where it was at this particular time of day, but we'll just say it would look something like that. So here's the challenge of any house system, and specifically when you're using diurnal arcs, we somehow want to connect the idea of 1/3 of the daily motion, because daily motion is closely tied to houses, right? Daily motion is tied to houses. So the intuition is, let's use daily motion, but how do we connect the daily motion, which is in these diurnal arcs, to the ecliptic plane? Here we have these circles, concentric circles, and then we have the ecliptic plane. How are we going to connect them together? The intuition behind Placidus houses is very cool. Placidus houses says this: let's just find the diurnal path, because this is the daily path. Let's find among these diurnal paths, you have a lot to choose from. There, any of these paths that are all concentric, all parallel to each other. Let's find one of these that where it crosses the ecliptic plane will be 1/3 through its path. That's it. Let's find the diurnal arc. It's going to be one of these. I don't know if it's this one or this one or this one. Let's find one that is 1/3 through, crosses, or we say intersects the ecliptic plane 1/3 through its path, and I'm guessing it's this one. I don't actually know, but just visually, it looks like about 1/3 to me. It doesn't matter whether it's actually 1/3 or not. It's just for teaching purposes. Let's imagine that this point here is 1/3 of this arc, this dashed orange arc, from rising, going up. I'm 1/3 of my way up, 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 and 2/3 more, and I reach the top. Whereas if I took an arc like this, well, let's do this one. It's not that far away. It's just a little closer to the center. This diurnal path goes up, up, up. I still haven't reached the ecliptic plane, I haven't reached it until I get here. Now I get here, and I'm 2/3 through the way. So what we have to do to create Placidus houses is find out which diurnal arc will take us to that point, and then this point is the 11th house cusp. I put 11. That's the cusp. Whichever diurnal arc will get us 2/3 on the up on the ecliptic plane will be the 11th, whichever one does the 12th, and similarly for all the other houses. They're going to be 1/3 and 2/3 through those each of those quadrants, each of those semi-arcs. This is called a diurnal semi-arc, and this diurnal semi-arc is the same size, and then there's a nocturnal semi-arc down here and another one down there. Okay, so that's it. That's how it's done. I've even put here 2/3. It's 2/3 from here to here, and 1/3 from here to here. And similarly, 2/3 from here. I put 2/3 here up to here. I put the 11th cusp, and then 1/3 the rest of the way. I've got some notes here about Alcibiades houses. I was thinking about including that in this lecture. Don't worry about that. I decided not to cover too much in one lecture, and I came up with some more interesting details about Placidus. So I'm just going to devote this to Placidus houses. You got it? That's the idea. What's amazing is the ancient astrologers thought so deeply about this stuff, cared about it so much, and worked out the mathematics, believing that these divisions of the sky had real significance in our lives. Really an amazing amount of work that was done to try to develop a model of how astrology works. So that's it. Again, this point will work perfectly for the sun and works perfectly for the projected position of a planet on the ecliptic plane, because the planets, other than the sun, are not exactly on this plane. For example, Mars might be over here, a little bit off. Maybe Jupiter's over here, a little bit off, and we're using the point on the ecliptic plane. And what happens is this point here, the 12th cusp, is that if the sun is in this house, as soon as it reaches this cusp, it means that it's 1/3 of the way up this arc. It works perfectly. I'm going to demonstrate some information you can pull up in the Series 2.0 software that confirms this. That's it. That's what Placidus houses are all about. One thing that makes them very compelling is that these diurnal arcs are part of an in-mundo system, and the in-mundo system is extremely important in ancient astrology. Probably should become more important in modern astrology too. In-mundo meaning measuring in these diurnal arcs from the horizon to the meridian. They're just very important, and the way they interact with the ecliptic plane is what forms the house cusps. So that's it. That's Placidus houses. Now let me show you something very cool. We're going to use the time adjust feature to show that what I told you is true. To demonstrate, it's not like a proof, but I think you'll find this interesting. So here's a chart for 4:20 in the afternoon on December 23rd, 2014. The sun is coming close to setting. It's in the 7th house. I'm going to use the time adjust feature in Series 2.0, and let's put the sun on some cusp. And what I'm claiming is that when we put it on, say, the 12th house cusp, then the sun will be 1/3 from the ascendant to the midheaven in its diurnal path. Or you could go in the other direction. You could say it's 2/3 from the meridian plane to the eastern horizon. So let me show you something. First we'll do the time adjust. And let's put the sun on the 12th cusp. So I'll click on time adjust. And I'll say put the sun, I've got all these features here, on the 12th cusp. And I say find time of aspect. So it'll go around, planets rise in the east, it'll keep going forward and find out when the sun's right on that cusp. So I'll say find time of aspect. And it does it. And it puts the sun at 2 degrees, 28 minutes of Capricorn. There's the 12th house, 2 degrees, 28 minutes of Capricorn. I've got Placidus houses selected. So I'm claiming that this sun is 1/3 of the way to the midheaven, not in zodiac longitude, but in its diurnal arc. So I'm going to save this, and I'm going to bring up a table that shows these in mundo values. There are a few places in Sirius we can bring it up. One place is if you go to forecast and primary directions. I click primary directions list, and then I get this, let me drag this to the middle of the area I'm capturing. It says complete speculum. That would show it to us. It's often called a speculum, or two methods with speculum. Another place it shows up is if I go to listing fixed stars, happens to be one here as well, and it says number 8, fixed star speculum, rise, set, culminate, anti-culminate. This is a table used by some astrologers who practice sidereal astrology. I'll just select this one. Happens to give us this table of values. And I scroll to the bottom, shows all these fixed stars. And this is a table that's often used for confirming calculations and determining primary directions or any in mundo position. And these last two columns here, it says east horizon distance, is what EHOR dist, and west horizon distance. This is the distance along that the diurnal and nocturnal paths, because that's what is used in mundo calculations to calculate the distance of an object, say a planet in this case, from the eastern and western horizon. That's how it was done throughout the Middle Ages. And that's what Placidus houses is also based on. So what this is saying is that the 20.098 negative, just don't worry about the negative and positive. In this case, it just means 20 degrees above the eastern horizon and 100 degrees past the western horizon. So the total number of degrees in the diurnal arc for the sun is 100 plus 20 is 120 degrees. And it's 20 degrees through that at this moment. So let me show you something with a calculator before you fall asleep. I'm getting into a lot of numbers. Maybe it's sounding boring, but let me show you something. If I divide 20.098, this distance from the east horizon, by the total distance, well, what's the total distance? Well, I better add this first. 100.464 plus 20.098, 120.562. So if I divide 20.098 by 120.562, is that what I said? It's 0.1667. That's 1/6. If I multiply this by 6, I get 1.000. What I just did there is I showed that 20.098 is 1/6 of the total diurnal arc. The total diurnal arc is the distance from the east horizon plus the distance from the west horizon. These two values are measurements along the diurnal arc, and 20.098 is exactly 1/6 of the distance. And here, this is a new feature I just added today. Let me close this calculator window. I just added this today, and if you have Series 2.0, you can install the update to get this column. I decided, why don't I give this to you? I'll divide the 20 by that, and then show where it is. It's at 12.000. I love it. I love it when the numbers work. In other words, what I'm saying, let me close this, is that the sun is conjunct the 12th cusp using Placidus houses. And when we look at the technical details of the semiarcs, we find that the sun is in fact 1/6 of the distance from this horizon to this horizon in the full diurnal arc, which means it's 1/3 of the way to the meridian plane, which divides this in half. So there you have it. It's just to show you that the table confirms the values, and also to show you this. Let's do one more example. Let's do the 11th cusp just real quickly, and then I want to show you the moon, because it won't work for the moon. It won't come out to be perfect. Let me show you one more example with the sun. We'll go to time adjust. We'll change this to 11th cusp. We can find the next or previous, doesn't matter. Find time of aspect. Let's save this. There's the sun exactly on the 11th cusp using Placidus houses. And now I've already selected this listing. There's the sun, conjunct the 11th cusp. Look at that listing, and when we go down, we'll see that the sun is 11.000. It confirms. This is measuring that the percent of distance of the sun from the east horizon to the west horizon is exactly placing it in the 11th cusp, two-thirds of the way from the ascendant to the midheaven, which is the same as 1/3 from the ascendant to the descendant, from the east horizon to the west horizon. It's right on the 11th cusp. So this just confirms that Placidus houses are measurements along the diurnal path of the planet to make sure that you're the right percent through it to be that cusp. That's all it shows. And the last thing I'm going to show you is this, is that it doesn't work for the other planets. And this starts to have some relevance to you as an astrologer, is let's do a time adjust and move, it doesn't matter, let's move the moon to one house. Let's just move it to the 12th house. So I'll go to chart adjust, and let's select the moon. So I've selected the moon to the 12th house, and let's say find time of aspect. So now the moon, 5 Aquarius 05, 12th house, 5 Aquarius 05, it's exactly on the 12th cusp. Let's save it. Now, question, are we going to get the same result we got with the sun, where the percent of the moon's semi-arc from the moon to the horizon and moon to the western horizon, that it's going to be that perfect 1/12 of this distance, 1/6 of this distance, which is the same as 1/3 to the halfway point. Will it match up? No, it won't, because the speculum is using the actual moon, the real moon, not the projected moon. So let me show it to you. When we go to the speculum, this table, the moon, the house position, which in other words is the percent of the distance from the eastern horizon to the total distance of the semi-arc, is 11.78. It's only 4/5 through the 11th house. And this is saying it's 0.78 through the 11th house. Bottom line is this, and this starts to be important for us as astrologers. If we want to use the actual moon, not the projected moon, and get a true house position, the moon's in the 11th house. It's about 4/5, 78% through the 11th house. It's not actually extremely close to the cusp. It's 20% of the way into this house. So it's not that close to the cusp. It's not right on the cusp. But using the normal way of doing Placidus houses, based on which uses the projected position of planets on the ecliptic plane, the moon's exactly on the cusp. So there's a choice with Placidus houses. Do you want to use the normal, typical Placidus houses, or do you want to use a true Placidus house position? If you want to use a true Placidus house position, you'd have to pull up a table like this that would list it. There is not a simple way that I can think of anyway that you could put it on a chart wheel, because it's more of a 3D approach. It's a spherical approach where we're taking into account the actual bodies, the actual physical positions of the planets, and they're not in a perfect circle. So that's it. This, I hope, has given you a good idea of what Placidus houses are, and that they're closely tied to the fundamental ideas in mundo astrology. I think the Placidus houses are impressive. They're elegant. They're built on a fundamental idea that we want to look at planets in mundo and measure them in mundo, and to do that we use these diurnal arcs, is the way it was done throughout a large part of the Middle Ages, and still being used today. I think starting to be used more often as people realize that the astrological tradition is not just about the ecliptic plane. It's also about houses and quadrant systems and how things are related in mundo, in relationship to a horizon and a meridian plane, which is more of a, you could say, a 3D, a spherical approach that you can't completely see on a piece of paper, and it moves us out of this. Somewhat ironically, the ancient astrologers were visually more sophisticated than we are now, and more aware of the complexities of planetary positions, and they took that into account. So which house system is better? That is, different astrologers are going to decide based on the evidence. All of the house systems have a beauty to them. Campanus is very beautiful. They're based on an elegant kind of geometry. The Placidus houses, I think, are very elegant and very consistent with a long tradition of astrological thought. The only question in my mind about Placidus houses, if they actually would work, is whether we should use the normal Placidus houses or whether we should use the true Placidus house positions. And I showed you a way in Series 2.0 to bring up a table that would show that. If there's increased interest in this, I might have to add a feature to just show it in a table like this in the chart wheel. But these are ideas that most people are not aware of. As they become aware of them, they begin to make requests, and we add more features to the software. But I did show you a place where you can at least get the position. Okay, I'm almost done. There's just a few more points I want to make. This is an interesting technical point. For those of you who are curious about these things, there's no direct way using spherical trigonometry, at least nobody seems to have ever discovered one, to calculate Placidus houses. It requires a looping process. So if we go back to our diagram, to find the diurnal arc that intersects the ecliptic plane 1/3 and 2/3 through, what you do, believe it or not, is guess. Sometimes there isn't an elegant solution, so you would guess, well, maybe it's this one, and then you say, well, no, that's not 1/3, and then you move it over, and you keep going back and forth till you find it. Believe it or not, that's how it's done. It's done with a looping process. It actually takes longer to calculate Placidus houses than other houses, because it has to loop around, or we say iterate, to find it. It's just guess, and then guess closer, and guess until you get it. That's just a curious thing about it. Not that important, but I just thought I'd mention it. And one last thing, which is this. Sometimes Placidus houses are called time-based. I read this all the time. They're time-based, they're time-based, they're time-based. And Koch and Alcibiades are time-based. The others are space-based. Well, in my opinion, it's not entirely true. You can think of it as time-based, but you can also think of it as space-based. Because what you're doing is you're taking a path, a diurnal path, and you're dividing it into thirds. It is true that a planet travels along this during the day, but it's also true that planets travel along the ecliptic plane. But what we're really doing is dividing this arc into thirds. So we're doing the same thing we do with all houses. We're dividing something in thirds. What's interesting about Placidus houses also is that rather than project on the ecliptic plane, for example, with Campanus houses, if you listen to the other video on how to calculate houses, we take what's called the prime vertical, divide it into equal sizes, and then project those points along that prime vertical system, and where they happen to cross the ecliptic plane becomes the cusps. The clever thing about Placidus houses is rather than measure along one of these diurnal arcs, and that's what the Alcibiades and the Koch do. They find one of these arcs, they measure along, and then they find a way to project on the ecliptic plane. What's very clever with the Placidus houses, rather than needing to project on the ecliptic plane, you're simply finding the point on the ecliptic plane which is already that equal division of the arc. You're finding the arc that will give you the 1/3, and then find another arc that gives you the 2/3. And the beautiful result of that is that the sun and also the projected positions of all the planets on the ecliptic plane do exactly what we want. It achieves exactly what we want. The sun will be, let's go back to the chart wheel, the sun will be in the 12th house. It will be in the 12th house when it's in that first third of the arc. And when we put the sun exactly on the cusp, it becomes exactly that percentage of the distance. So it in fact works out to what we want. So that's Placidus houses. I think I've covered everything. Any other notes here? They're actually space-based. Last note is I want to give credit to these two websites, uraniatrust.org, a specific website address, and at quadablock.com, another specific page. I studied these two website pages very carefully, and some others. I basically remembered from years ago there were books from decades ago that I read on how houses are calculated, and I've worked with these things. So I remembered the basic idea, but to make this presentation, I had to brush up, and these two websites were very, very helpful. And in the process of doing it, I have to say, I've gotten a much clearer idea of what Placidus houses are, and it inspired me to create these true Placidus house positions. Hadn't really thought about these things much before I made this particular, this tutorial video. That's it. I hope that helps you get an appreciation for what Placidus houses are, for what diurnal arcs are, and in mundo, and how all these things are really an important part of the tradition of astrology. Thank you very much for listening. God bless. Namaste.